Good afternoon. My name is Ravi Babu, Assistant Professor in Electrical and Electronics Engineering Department, IARE. In last section, we see the pulse transfer function concept, and now today I are going to realizing of the direct realization of the pulse transfer function. Direct realization of the pulse transfer function. So for that one, first of all, I am taking the one of the transfer function, that is G1 of Z. In this section, the above block is called as a forward path, B0, B1, Z minus 1 plus B2, Z minus 2 up to some B, Z minus 1 by, I am taking here negative feedback. That's why here we getting positive 1 plus, and this is your feedback path, forward path and feedback path multiplication factor. In this case, I am considering this condition is under m less than or equal to n. M less than or equal to n. Another one, for realization process, I am taking here one more transfer function, that is G2 of Z. Where in this case of the G2 of Z, we are going to taking the 0 values, that is numerical values, numerical terms, that is called as the 0 values. Okay, in transfer function, that is B0 into Zm plus B1 into Z minus M plus B2 into Z minus M2, like this. Now, in case of here, second function, I am taking as negative feedback function also, that in the form of Z power of n plus A1 into Z power of n minus 1, like this. It is also in case of the m less than n condition. If m equal to n, then we are going to making a possibility of G1 of Z equal to G2 of Z. Now, I am going to realizing these two transfer functions, pulse transfer functions, that is G1 of Z and G2 of Z. I am going to realization. For that one, first of all, I am considering G1 of Z. So, by definition of the pulse transfer function, G1 of Z equal to Y of Z by U of Z. That equal to, I am taking the first equation. This is our first equation. I am going to making here cross multiplication, that is input section and output section. Okay, input section and output section. That is the feedback path. The feedback path with the negative feedback path is multiplied with output and forward path. That is, this forward path is multiplied with U of Z. Okay, what I am doing is, I am taking the pulse transfer function, and for that pulse transfer function, we are going to making the multiplication with input and output terminals. After that one, applying the inverse Z transform, that is Y of Z is converted into Y of K. So, if you multiply this one into 1, it is coming to Y of Z. So, apply inverse Laplace transform, that is Y of K. Next, plus A1 is there, A1, it is Z inverse of minus 1. That is, step function is with 1 minus category. That's why it is coming to as Y of K minus 1. Similarly, for infinity functions, that is An of Z, Y of K minus N. And coming for the input section side, in case of the input section, here also apply here inverse Z transform. So U of Z into B0. So B0 into U of Z is coming to as U of K plus B1 into B1 is function with delay of 1 unit. That's why it is Z to the power minus 1. When converted this one into inverse Z transform, that is, it is coming to as U of K minus 1. So for infinity term, Bm into U of K minus M. Now, For simply mathematical calculation, that is, we required only y of k relation. Realization, no? That is, we are going to realizing the function. That's why we are getting here y of k. Y of k equal to this part, total part is coming to negative section plus input terminal b naught into u of k. This is the input terminal. Input terminal. So applying for this one is summation function for mathematical calculations. So it is coming to as for n sections. Okay, here we taking the n section for a of n, no? So n sections, applying a summation function I equal to 1 to n a I y of k minus I, where I equal to 1 to n. Okay, similarly go for the input section side, apply for the summation function, that is sigma I equal 0 to m. Okay, b I u of k minus I, where I equal to 0 to m. Okay, this is your output in terms of the input terminals of the pulse transfer function. Pulse transfer function for a step also. Okay, now take the condition, that is, in previous slide we said, no, for m equal to n, what happens in that case? If you take m equal to n, it is coming to as where m is there, it is coming to n. Okay, where m is there, it is coming to n. Now I am going to writing the realization function. Okay, realization function. For writing this realization function, first of all, observe this one equation. That is, input is u of k. How many terminals are will be there? See this one, equation 1. Okay, otherwise, get right. What is that one? B naught plus B1 into Z1 power minus 1. Okay, plus B2 into Z power of minus 2 up to so on. BM, Bm Z power of minus m by 1 plus a naught, a1, first function a1 up to so on an z power of minus n. Z power of minus n. This is a function, no? One of the transfer function. Now, draw the realization formation. Okay, for this transfer function. Coming for here, it is y of z by u of z. Okay, after multiplication for input section, output sections, equations with the transfer function, y of z is coming to after applying the inverse Laplace u of k, no, in equation. Okay, u of k. Next, it is coming input part. Okay, how many z minus 1 will be there? M terminals. Okay, m terminals. That's why I am taking z minus 1, 1, 2, up to so on, n. Up to so on, n. Okay, so it is B naught is coming here. This is your B naught plus, okay, z inverse of minus 1 into B1, see that one, plus up to so on B n minus 1, okay, it is m minus 1, B m minus 1 up to so on. Okay, it is our function. It is zero feed forward path function block diagram. Forward path are zeros in case of the transfer function. In case of the transfer function, it is numerator part is zeros, no, and forward path block diagram. After that one, what is remaining? Denominator part, that is feedback path. 1, 1 plus a1 into z minus 1. Z minus 1. Negative feedback, no? So it is coming to as positive. It's coming to as positive. So 1 minus at a plus. Okay, a1 into, it is terminal with z1, no? Z1. a2 is terminal with what? 1z, 2z. That is why it is coming to as my z power n. Right? Up to so on, an is there. Okay, up to z power of minus n. It is coming to as. It's coming to as like this. Okay, this is your direct relation of the pulse transfer function block diagram, general block diagram. Now I am taking one of the example, that is problem. See the problem. Obtain the relation of the pulse transfer function, that is g of z equal to z square plus 9z plus 20 by z cube plus 6z square plus 11z plus 6. Okay, so find out for this one. So it is coming to as y of z by u of z. Okay, cross multiply. So u of z into that part. Equal to y of z into this one. Okay, apply u of z transform. So what happened? It is coming to as z power minus 2 like this. So don't go for like this big side, big problems. Just simply the function. Don't make multiplication factor same as a previous section I am derivation part. Don't go like this. Directly go for the problem. Okay. First of all, identify the order of the poles. That is, which of the order is more in poles or zeros. Anything. Here in the problem, the poles is having the more order. That is, how much order? 3. 3. Order nothing but what? In previous classes, that is, otherwise in control systems, I already explained this one. Order is nothing but the highest power of the value. It is called as a order in denominator. Okay. So what is the order? That is nothing but z cube. Z cube is there. The order is 3. So order is 3. So z power of minus 1 is coming to as 3 terms. 3 terms. Okay. Completed. Next. Up to here all of you? No? The order of the function is z power of 3. That is nothing but 3. Order is 3. So in case of the relation method, z power of minus 1 is coming to as 3 terms. 3 terms. Okay. Z power minus 1, these 3 terms. After that one, see, coming for the, it is feedback path, it is forward path. Okay, it is feedback path, it is forward path. Coming for the first forward path. First forward path, it is z square. The order is 2. So 1, 2. 1f forward path, 2f second forward path. So it is coming to us from here. 2 is coming. Okay, 2 power. So coming to here, 1 multiplication plus for z only single is there. Z into 9 plus 20 like this. It is forward path relation. 1 z plus 9 1 z square plus 9 z plus 20. Okay. Otherwise, if you go for in this also, okay, here plus is there, no? Addition, total addition. 20 plus 9, z power of minus 1, that is z. Okay, here plus how many square? Z square. Why? Because it is 1, it is 2. So 1z square. It is plus z square plus 9z plus 20. Okay. Now coming for the feedback function. Coming for the feedback function. In case of the feedback, we are having the z cube directly plus 6z square. Okay, plus 11z plus 6. Okay, plus 6. So, see this one. Z cube. So, how many terminals will be there? 3 terminals. Next, 6z square. 1, 2. 6z square. Okay, 11z. 11z. Okay, plus 6. Plus 6. Okay. All of understand? Go for 1, 2. So 1, 2, 3. So z cube plus 6 into, I don't know how much here before this one, 2 z square plus, for this one 11, before how much z will be there? 6 z power of minus 1, sorry 1, 6 z, sorry 11 z1 plus 6 plus 6. Okay, this is the direct relation of the one given pulse transfer function. Pulse transfer function. Okay, direct relation of the one of the pulse transfer function. Now I am going to one more problem, that is your obtain the relation of the pulse transfer function. See this one. In this problem, they given as 5 into 1 plus 0.25 z inverse. Okay, 1 minus 0.5 z inverse, 1 minus 0.1 z inverse. Always, when you are going to drawing the direct relation of the problem, always the given transfer function is in the form of z only, not z minus 1, not z power minus 1. Okay, remember that one. Always the function is in the form of z only. Z only. So first for that one, first multiply this one function 5 plus 1.25 into z power of minus 1 by 1 plus, okay, 1 plus multiplication of these two coming as 0.6 z inverse of minus 1 plus 0.05 z inverse 1. After that one, we are going for the standard formation equation for transfer function, pulse transfer function. Here z power of minus 1, minus 2 will be there. So multiply with this one with z power of square and z square, divide and multiply. Okay, so what happened? Z square into minus 0.1 into z power of z plus 0.05, that's all. In denominator 5z square plus 1.25 z. That is, always we have to maintain the function in the form of z form only. Z form only. Why? Because whenever going to drawing the relation function, and the relation is in the form of z inverse only. In the form of z inverse only. So that's why I am taking this example. Okay. See this one. It is a modified your function. This is your modified function. For this one, I am going to writing the direct relation diagram. Okay, direct relation diagram. First of all, what is the order of the system? You have to identify. The order is 2. The order is the z power of the value is highest value is z square. That's why order is 2. Okay, for 2 orders, z power of minus 1 terms is coming to as 2. 2. Completed. After that one, see z square. I am going for feedback path. Z square. Okay, z square 1, 2. Next, minus 0.6 into z. 0.6 into first term, second term. That's why z square. Next, minus 0.6 into only one term is there in this link. 0.6 into z. Okay, so it is completed. Next, coming to here, plus 0.05. This is diameter part. This is diameter part. Now, going to numerator part. Okay, 5z square. That is nothing but 1, 2. 1z square, first z, and that is nothing but, if you take the inverse Laplace transform, it is all going to z. It is coming to as z. It is coming to as z. These two are in cascade. So what happened? Z square into 5. 5z square plus coming to here. Coming to here, it is plus. After that one, 1.25z. That is nothing but, from here I am taking, it is z power minus 1. Nothing but z. Okay, into 1.25. 1.25. Okay, this is the function for writing the direct relation in the form of problems. Okay, it is the way you have to write down. It is forward path, it is feedback path. Okay, next, remember that one is, here there is a link for the no link for this one from here. Compulsory block will be going to feedback and going to this way. Okay, in previous section there is a link, that is in numerator they given the 20. Here in the numerator there is no given the constant term. Constant term. Okay, so that's why it is coming to as feedback only directly. After feedback function, they are going to, for the function is going to be in the feed forward path. Into the feed forward path. Okay, now this is your problem for in case of the direct relation term. Direct relation terms. Okay, these are the references books. Okay, tomorrow I am going to start it with the parallel operation of the, okay, parallel relation of the pulse transfer function. That is, when the two transfer functions are connected in parallel, in that case, how can you realize the parallel function of that one? How can you realize the parallel function of that one? Thanking you.
Like, share and subscribe. Hit the bell icon for more updates.